Alright, I'm Brandon. We're doing the elevator extra credit. So basically what we're doing here is we are measuring a mass, which will be me in an elevator, and we'll be looking for 4 different accelerations. The initial as the elevator starts going up from the bottom floor, and then the acceleration at the top as it's slowing down, and the initial as it's going down, and the final as it reaches the bottom floor once again. Alright, and so looking at our hypothesis for this experiment, if we are solving for the acceleration of an elevator, then the initial accelerations will both be positive, while the final accelerations will both be negative. And we know this because for the initial accelerations, the normal force will be greater than the force of gravity, leading to a positive acceleration, while for the final accelerations, the normal force will be less than the force of gravity due to the lighter mass, and this will lead to a negative acceleration.
Brandon's weighing in at about 63 kilograms.
Rope gang.
Right. And then just going down.
Okay.
Alright. Second floor again. This time we're going up. Alright. Alright, so right now we have the information for Brandon, and he starts in weighing at 63 kilograms, and while he's going up, he starts at 66 kilograms. Then as it's stopping, he weighs in at 57 kilograms, and then when it's going down, he starts at 58 kilograms. Then when it's stopping, he weighs in at 55 kilograms. Alright, and to calculate the force of gravity acting on Brandon, that's his mass times the acceleration due to gravity. And so force of gravity equals his mass, 63 kilograms, times 9.8. And that leaves you with 617.4 newtons. Alright, and to find the acceleration of when Brandon goes up the elevator starting, we have to find his normal force when he goes up, which is his mass, 66, times 9.8. That gives you the 646.8 newtons. And then to find the acceleration, you have to do normal force minus Fg equals mass times acceleration. And then if we substitute all the numbers in, it's 646.8 minus 617.4 equals his mass, 63 times A. And then that'll equal out to 29.4 equals 63A. And we can divide everything by 63. That gives you 0.466 meters per second squared of acceleration. Alright, and to find the normal force of Brandon when the elevator stops when it's going up, again we do the mass times 9.8, which is 57 times 9.8. That gives you a normal force of 558.6 newtons. Then again, force of normal minus force of gravity equals mass times acceleration. So we plug that in, 558.6 minus the 617.4 at rest equals his mass times acceleration. And then that gives you negative 58.8 equals 63A. And you divide 63 again, and that leaves you with negative 0.93 meters per second squared as the acceleration.
Alright, and then so in solving for the initial acceleration as the elevator begins its descent back to the bottom floor, what we're going to do is, once again, put our force of gravity equation at the top here. It's just a reminder, 617 newtons. And we're going to write our equation we're going to be operating with. Normal force minus force of gravity equals mass times acceleration. So then what we're going to do is start plugging in our numbers here. So it's going to be 58 times 9.8 for normal force minus the force of gravity, which we already solved for, is equal to 63 kilograms my mass times acceleration. And then so in simplifying that, I get 49 newtons is equal to 63 times A, and we're going to get our final answer of acceleration being negative 0.778 meters per second squared. Alright, and so we're going to be solving for our fourth and final acceleration here as the elevator approaches the ground floor once again. So what we're going to do is just put up our force of gravity calculations here as a reminder, 617.4 newtons. And once again, reminding ourselves of the equation we're going to be using to solve for this acceleration. And then so inserting our numbers for this particular calculation, we're going to get force normal minus 617.4 newtons is equal to 63 kilograms times acceleration. And so in simplifying that, we're going to be left with negative 78.4 newtons is equal to 63 kilograms times acceleration. And dividing both sides by 63 will get us the acceleration, which ends up being negative 1.24 meters per second squared.
Alright, so the magnitude of the direction of the acceleration is going up. First, the acceleration is going upwards because it needs that little push to get the elevator starting. So that's right here. And then the second is when it's going up and then it's slowing down. It needs to have a negative acceleration going downwards because that's what is slowing the elevator down, or else it'll just keep going up. And then when it's going down, first acceleration is slightly smaller negative because it wants to go down faster than it is, and it needs that negative acceleration going up to slow it down. And then also that's the same for the second acceleration down because once again it's going faster than the top one and it wants to push itself up, or it needs that acceleration up so it doesn't go down too fast. And then in the middle of the trips, at some point the accelerations have to equal 0 because at that one point the elevator is going at a constant speed.